So in our last class, we started talking about the human fingerprint. That is, how do we know that we are the source of greenhouse gases? That is fossil fuel burning primarily. And we talked about a couple different things. First, we talked about the timing. That is that the increase in carbon dioxide in the atmosphere is suspiciously coincident with the beginning of us burning fossil fuels. And secondly, we talked about the correlation. That is that our increasing of burning fossil fuels is highly correlated with the increase of carbon dioxide in the atmosphere. That is at about 99%, which is pretty darn correlated. But as you know, correlation is not causation. So these two sort of proofs have some sort of wiggle room that is not convincing to everyone. So then we also talked about the unique chemical signature of fossil fuels. First, we talked about carbon-14, and that really old carbon, that is carbon that comes up out of volcanoes or is burned in fossil fuels and added to the atmosphere, essentially has no carbon-14. So if we add a bunch of this to the atmosphere, it will dilute or sort of deplete the amount of carbon-14 in the atmosphere, and we're seeing that. And then secondly, we talked about carbon-13, and that plants, whether they're old and dead in fossil fuels or currently living, are depleted in carbon-13. That is, they don't really like to take it up. So they tend to take up more 12 than 13. So if we burn a bunch of fossil fuels or currently living plants, the atmosphere will become sort of diluted in carbon-13 or depleted, and we see both of these things happening. So the common thread between both of these things are the fossil fuels. So this is seen as pretty strong evidence as to what is the source of the carbon dioxide in the atmosphere. And then finally, we talked about atmospheric oxygen declining. Don't worry, not to dangerous levels. We should be okay. But if we were burning a bunch of carbon, we would expect it to be declining, and it is. So all of these things sort of taken together start to really implicate fossil fuel burning, or our fossil fuel burning. So the last point, which should be number 5, but apparently didn't change that, has to do with modeling and the way that we have attempted to model temperature changes over time. This first figure is showing you temperature increases over land. This is showing you land and ocean surface temperature combined. And then this last figure is showing you ocean heat content, with the black lines being observed data. So when we try to model this temperature change, if we only use natural forcings, that is these blue shaded areas, we can't capture that temperature change. But if we include human forcings like burning fossil fuels, which are the pink sort of shaded area, we do capture that temperature change. And this line of argument, or this argument or proof, I guess, not really argument, is often referred to as the smoking gun. So if you did the extra credit homework, this is what you saw. So in the next video, I'm going to talk about sort of the human fingerprint. How do we know it's greenhouse gases? How do we know it's not something like the sun, for example?